Thank you, David. Thank you to the organizer for having invited me to give this talk this morning. So this communication was prepared with colleagues from INAE in Toulouse and from Italia. So we'll we all know that sunflower is a major component of the rain-fed cropping systems worldwide, and we saw in the conference that oil is the main objective, and protein is getting important, but also confectionery. But but to me, sunflower crop has to address 4 new major challenges. First, how to mitigate the detrimental impact of climate change on production and benefit from some growing opportunities. Also, how to contribute to more ecological agro-system. And then how to increase the provision of ecosystem services by the crop. And what's been pretty important, their visibility. And with these 3 challenges, there is a crossing challenge, which is how to improve our capacity of ideotyping and breeding for this new challenge. That will be the main outline of my speech. Starting with climate change, we all know that sunflower production region will be markedly exposed and affected by climate change, and especially due to droughts. We know that most of the production is done in Europe, and this basin is mainly exposed to the lack of precipitation, and the scenario of climate change will predict an important lack of water during this period. So what makes the vulnerability of crop to climate change? First, its exposure to climate change, but also its sensitivity and its adaptive capacity. That's what we learn from the EPC works. And climate change, we'll know that it will be concerned by the increase of atmospheric CO2 concentration, increase of temperature, and generally a lack of precipitation, but sometimes not so the case. So it will have, as a consequence, increase of photosynthesis with increasing CO2, but the increase of temperature will reduce the duration of cycles and produce some heat stress, also increase the water demand for evaporation. And the lack of precipitation will increase the irrigation needs and the general deficit of soils. Concerning biotic interaction in general, we are not sure of the sense of the variation. Okay. Thanks to numerous crop growth models, we can predict the impacts of this change on production. And here are an example of 2 models that simulate that we will have some deep impact in rainfall systems with no adaptations. For instance, a decrease of grain yield in rainfall systems. In general, that can depend on the scenario of climate change also, and of the climatic model, but in general is the case, a shift. But in irrigated system, you see that an increase with climate change. That could be due, probably, with no adaptation to the effect of CO2. But there is also some opportunities that will be possible with climate change. For instance, extending the growing area northward, especially. But all that is a change in new set of climate constraints, the higher CO2 in the atmosphere, the possible new biotic stresses, and the new production environments, and new cropping systems that should be adapted to this change of climates. All that will change the traits or the types that we have to manage, and the regional distribution of the approach. There is different options of adaptations. Generally, when we are thinking to irrigations, but water resources can be limited. But here we are speaking a lot of breeding as a physiology or technology. We can change and shift the planting date, for instance, change the region where we want to produce that, and we can use also some double cropping in some situations where water is available. So I will illustrate with three examples this adaptation, the consequence on the traits in the Alps. So we will know also that sunflower is a moderately drought-tolerant crop, but anyway we have to breed for more tolerant to water stress. And we saw a lot of examples in this conference. I will not develop, but we know that sunflower has a high capacity to extract water from the subsoil, and a sort of plasticity that make possible to mix adaptation of leaf area development to available water, and it results in different strategy of response to this scenario. And numerous traits of response have been reviewed in the literature, and you will see in different conference more detail on that. I will not insist on that. The second strategy is to breed for early sowing, escape strategy, and Philippe DEBAEKE talked about this strategy yesterday. By anticipating the timing of critical growth stage, you can change the exposure of sunflower crop to heat and drought and minimize it. That has been tasted in temperate regions by advancing sowing for one month in early spring, for instance. And in some Mediterranean regions, some arid regions, you can also sow in winter and with good results. And for that, you have a list of traits that you have to change for this, that are related to the chilling tolerance concerning base temperature, the vigor, speaking a lot of vigor here, the recovery after cold stress, even maybe the resistance to some predators or pathogens, because it takes time to emerge and to germinate and so on. But also there's the opportunity for breeding for late sowing, of course, and double cropping or second cropping. So, and we know that sunflower is a very attractive option for this practice, either for grain or energy. Just following the harvest, the early harvest of winter crops, often cereals. And the best crop management there is to sow rapidly with minimum tillage and no additional inputs and so on. But generally you will need some supplementary irrigation, which could be irrigation in some cases. And the variety traits to select are not new really, but it's oriented to very early maturity for groups. It's to low susceptible variety to sclerotinia, for instance, because at the end of the cycle you can have some wet conditions or reduction of decrease of temperature, for instance, and that's why ideotyping are maybe better adapted than oil. So this can be tested, that can be simulated also to see what's the best strategy. But it seems to me that in Europe, this hybrids often comes from the selection of very early materials that intended for northern parts of the country of Europe, and that the trial for this cultivar in the situations of southern conditions with double cropping is lacking until now. Just some illustration of experiments we did in Toulouse this last years to test different varieties in a double cropping system. And I will illustrate here that what's important is the trade-off between the potential productivity, so duration of the cycle, and the possibility to harvest at a minimum grain moisture, and You can see here that some varieties are more, sorry, it doesn't work. Okay. That some varieties are better positioned than another, and the trade-off has to be managed. And the other question is to find the best, to optimize the sowing date. You see here on this map that you have a maximum deadline for sowing dates in early summer in order to be sure to harvest a good green mold. So to try to find best situations and best management, hopefully we can use some models for that. That is an example of for instance, of sticks model that was used to simulate in the future what could be the potential productivity of this double cropping in irrigated conditions in red and in blue, in blue and in rain-fed conditions in red. And you see the variability of rain-fed in rain-fed conditions, but some year we can have some comparable results. This here is in the center-west of France, and we can also simulate or try to determine what is the best irrigation. Here is irrigation for potential, so it's not probably not an economic strategy, but we can simulate also some restricted or deficit irrigation situation. Now second part is sunflower and agroecology. I think it's a very important part. There is a general agreement, in fact, that we have to go to move toward more sustainable cropping systems. And the first step here is to develop pest management practice, soil conservation, for instance, integrated pest management, and general reduction of chemical inputs. So that's the first step, more or less a sort of eco-efficient system, which is transition to more sustainable situation. But the second part is to develop agroecological systems where we want to substitute the external inputs with biological processes, for instance, and try to diversify very strongly the cropping system, both in time and in space. Okay, so we know that in first time maybe the production could be reduced, but we hope that in the future with new plants and so on, new playground, we can have to productive system. So our sunflower can be faced with that. Still, we know also that everybody knows that sunflower is a low input crop. And I use here some recent results of survey on practice in France from Terre that show that sunflower is not irrigated, receive less nitrogen fertilization. Generally, it's plowed about less and less plowed now. Even it's difficult to have a direct sowing, for instance. There is a very limited application of pesticide in comparison with other crops, cereals. Mechanical control is possible, even it's raised now, maybe due to the development of very tolerant varieties. Cover crops are more and more frequent now before sunflower, that's good, and sunflower grown under organic farming is increasing. So there is a step for sunflower to work with more eco-efficient and ecological system. And breeding for low input management and organic farming, to me there is three main limiting factors: the weed infestations, the nutrient stress that could be limited in the system, and the disease attacks. So the weed infestations. We discussed of that already. We have to increase the competitiveness of the varieties of the crop and the varieties against weeds. We will speak once more of vigor and so on, but it's important to have a rapid growth and developments and a rapid canopy closure in order to try to control this early emerging events. Nutrient uptake efficiency, there is very little information on that to compare the genetic variability, but probably it should be related partly to the root system that is poorly explored because it's very difficult to do it. I won't speak on the aspect of disease attacks and disease tolerant resistance. There's a lot of efforts that have been done, as Felicity showed yesterday, and there is a lot of contribution on that. But if maybe in this system, in low input system, I'm not sure that the disease attacks are always the main limiting factors, because we have also less nutrients and so on, so the risk of development of disease can be sometimes reduced. Okay, but now do we have to breed for multiple cropping systems? We have new systems that are emerging. They are not major in area. Some illustration here of experimental systems for intercropping, for instance, or discussion about variety mixture. Do we have to do that in sunflower compared with cereals, agroforestry, and so on? And now there is no very little recommendation about that, and no specific target for selection. Concerning to soil conservation agriculture, I'm speaking a lot of that at this moment. No tillage, cover crops, rotations, but also relay cropping. I think that sunflower is not well adapted because of the problem of root taproot system and so on. But we can see in the future to improve that. Third part, the ecosystem services. Okay, this is new approach now in agronomy. We can not only speak of production as a service, but we have to consider a wide variety of ecosystem service: pest control, pollination, nutrient recycling, soil conservation, water provision, carbon sequestration, biodiversity. And I think that these effects have been poorly explored concerning sunflower in particular. We're speaking a lot of the interest of green legume and so on, but we could speak, I think, of the interest of sunflower for contributing to this ecosystem service. How to include that, and which traits and ideotypes. We did a literature review on that. It is in the book you have in your material. We consider that first that it contributes as a sustainment of biodiversity by providing nutritional resources, pollen, nectar, in early summer to pollinators. So not only the function of pollination, but also the function of feeding bees and so on. Also, they could contribute to environments by contributing, for instance, to phytoremediations. There is a possibility for heavy metal polluted soil, and we identified also the possibility to help to regulate the pest by the classical breaking effect in cereal rotations, but also by contributing to weed control in succeeding crops. And allelopathy could be something that could be explored. I will not develop this point because there was also a lot of contribution on that. And we saw in previous talks that, in fact, the production of hybrids hybrids with smaller flowerets could be something interesting to increase the visit of the bees and increase the pollination and so on. And so that could be also interesting for contributing to the viability of the bees. I saw in the literature, I'm not a specialist, but I saw that sunflower can be used very efficiently for phytoextractions of heavy metals, and it's very, very often used for that in polluted systems, because it has the possibility to accumulate this heavy metals. We don't have to start probably a breeding program on that, but first maybe to screen various genotypes and see the possibility for that. That would be interesting. And this hyperaccumulation activity could be also interesting for some biofortifications objectives, for instance, for human nutrition. And concerning allelopathy, I was surprised to see that there are a number of papers on that, and that sunflower is in the top rank of the crops that could be used for that, plant and tissues, and the contents of allelochemicals in plants and tissues can be very effective for controlling weeds in sunflower and in the next crop. So that would be also a way, contribution to biocontrol, and some studies showed that there was some difference between sunflower hybrids. So that would be interesting to maybe to explore more. So to face face this new challenge, probably the sunflower ideotype should consider other target traits that only the market-oriented ones. So we produce this wonderful flowers to express this multiplicity of objectives. When we look to what is available in the information for farmers, for instance, provided by the advisory systems after registration and post-registration assessments, we must see that there's a reduced number of varietal characteristics because it's very costly. It's probably not sufficient for variety choice with the multiplicity of objectives in such a diversified systems. So the question now is how to design ideotypes for this new context in our first part. I think that to provide varieties that are adapted to those multiple cropping situations and objectives, the stakeholders that are involved in selection, assessment, recommendation, the new objective is new methods. And I am sure that selecting a variety, this variety on a large number of objectives simultaneously is a real challenge, which is complicated and probably will be probably inefficient. But I'm not agree. And I presented here this three-step method, in fact, very schematically. First, define the varietal specification. Then you have to design and build the ideotype. And finally, you can select variety according to this ideotype and assess the ability to meet the specification. It's probably simple and more complicated in reality. But this ideotype approach is sort of frameworks that I think it could support this collective design. It facilitates the interactions between the stakeholders from different scientific and technical fields, and probably the use can use different forms of knowledge that could be scientific but also empirical. To help that, hopefully we have also some models, some process-based models that can be used for simulating the consequence of, to explore for the potential of different varietal traits in different conditions, future or unexplored conditions, the area of an example of the sunflower model we developed into this. But we have also some advanced phenotyping approach that make easier and possibility to have a high throughput approach to have access to these new traits. For instance, the canopy closure, new traits that can be explored, or the response to water stress, what we're doing currently includes in the platform. And this could be also very useful for calibrating the models. The evaluation of the variety should be also done in new cropping systems. That's the case of organic farming. For instance, you have to adapt to crop management. You will change the sowing date, or you will change the previous crop, or you will include mechanical wind control. That is free to reproduce something which is close to the system, and you have to include new criteria specific for evaluating the response of the variety in these systems. For instance, here, Carribigo, it's important to see the competitiveness against weeds, even if we have no weeds in this system. This is, I think, things that are starting because there is some now the dedicated organic farming network in Costa Rica. I think it's the case in Territoria, and there is some varieties that are developed specifically for organic farming too. So, when it comes to my conclusions, and I will not speak of breeding, I will not speak of that, of genetics. I will see only the implication for agronomy and physiology. This will necessitate for us to screen a wider range of genetic resources and traits, field, platform, and so on. We have to fine-tune ecophysiological indicators and methods of phenotyping, new methods, sensors, with people in charge of this technology. We have to develop a set of new experimental design for the G by E by M determinations, and this design should be applied to this sustainable cropping system, including new constraints. We have to represent this diversity in crop growth model and develop decision support for choosing variety using both vertical layer approach and coupled with crop model, for instance, for simulating the environment condition, but also for simulating potential traits and so on. That's the case of the Invite EU project in which we are involved with Stereo. Okay, and so thank you for your attention, and I will really thank to all my colleagues from United Rouge and GBS, Stereo and so on, because this is the result of an idea we exchange and data that during collaborative projects all these years, and projects that were always at the interface of agronomy, crop physiology and genetics, and including also the contribution of development. Thank you.